Okay, so welcome back, and now we're going to talk about converting from polar coordinates to rectangular coordinates. Okay, polar coordinates to rectangular coordinates. Again, this is very similar to what the work that we did. Comes directly from the unit circle, except again we've got concentric circles, so the radius is not 1, so radius is r. So the radius can be anything. So again, it's very straightforward from the work we did before. Okay, so if we have an angle with a radius, and radius is r with an angle theta, then we just use the trigonometric functions, the trigonometric identities that we developed before. So x, in this case, is going to equal what? X sine of theta is what? Cosine of theta is adjacent over r, which means what? If you solve for x, you get r cosine theta. That's the general formula. Okay? And so y becomes r sine theta, right? So all you're doing is taking the definition of cosine of theta and sine of theta and then solving for x and y appropriately. And so these become the equations for converting from polar coordinates to rectangular coordinates, because you'll know theta and r, so you just plug it into here, find x, and for here you plug it into here for y, and you're done. So let's do an example. So here we have three. So if we use this example here, we have 3 comma pi over 2, okay, and we want to find the rectangular coordinates for these polar coordinates, okay? The equivalent point, right? So again, we want to represent this point, the same point, using rectangular coordinates. So we're going to use the fact that x and y equal these. So we're going to say x equals r cosine theta, comma, y equals r sine theta, right? So what's this? This is going to be 3 cosine pi over 2, comma, 3 sine pi over 2. Okay, well, what's cosine of pi over 2? What's the cosine of 90 degrees? Well, 0, right? So this is going to end up becoming 0. And what's the sine of 90 degrees? That's 1. So this is going to end up being 3. And of course, that makes perfect sense from what we did. This is a 90-degree angle with a radius of 3. That'll put you right there at 0, 3 in rectangular coordinates. Okay, now, what about this one? Let's say negative 2, 0. Okay? So we want to write these polar coordinates. So here's another one. So in this case, this is negative 2, 0. Okay, those are polar coordinates, so don't get it mixed up. Okay? So in this case here, we're going to again use the formulas. So we know this is r, comma, and this is theta. So that means x is r cosine theta, which equals negative 2 cosine 0, which equals what? Well, cosine of 0 is 1. So that means this is going to be negative 2. And then if we do y equals r sine theta, which is going to be negative 2 times sine 0. Well, sine of 0 is 0, so this is going to end up being 0. Well, look at that. This actually gives you the same numbers. Now, be careful. Won't always do that. It won't always do that. So in this case, we found that negative 2, 0, when we're talking about radius and theta, is the same as the corresponding xy coordinates. Okay, that's it. So next time we'll start talking about how do we convert from rectangular coordinates to polar coordinates.